And now I have to introduce the MPAS atmosphere model. Here, MPAS means model for prediction across scales, and A means atmosphere. You may be interested once you look at the figure because it is not using rectangular grid. It is using unstructured grid. And the grid cell in this unstructured grid are mostly hexagonal. Like this one, if you plot it horizontally. But if all cells are hexagonal, it cannot make spherical surface. So some cells, at least some cells are pentagons, having 5 sides. This combination is just like a soccer. 嗰啲足球上面嗰啲一塊塊嗰啲皮釘埋去變咗個縮球咧，就一定係有啲格仔咧係5邊形。And this is the website of this model. This model is great. And actually, the CPAS website is a modified version of this MPAS model. This model is open source and have a license terms that allow people to reuse it and modify it. So we did that. And this is a figure to depict something. Two-dimensional plot will often give confusing understanding to you because you have the real thing is 3-dimensional. So going up, there are many vertical layers, and we can plot it like a hexagonal column or cylinder going up. And in real world, the NWP models have denser vertical layers near the land surface. And going up and up, the vertical layers are usually less dense and less dense. But high in the sky usually have a constant vertical spacing. And in numerical forecast model, you have to represent the real world. You will see in toy model, if the real world is homogeneous, then the weather will not be something we experience day by day. There is heterogeneity on the Earth's surface that drive different weathers. So the key elements that affect weather is whether the land surface is water or land. So this is represented here. And for land, there are different land use or vegetation. They affect many things we will talk about later. And then the model will consist of a simple model of soil also, because soil moisture is important. And also there are mountains on the Earth's surface. So the terrain have to be present in the model. So that it is actually represented by terrain height data and also the horizontal grid. So if it is on a hill, then basically you just think of the whole vertical column shifted up, and below the Earth's surface, there is a vertical distance between one cell and its neighbor. So these are important aspects of the model. And as MPAS itself stress on prediction across scale, MPAS itself supports variable resolution mesh. Just like this figure show, if you want a more detailed simulation over a region like North America in this example, then the mesh become denser and denser horizontally. So the resolution is fine here around your region of interest. And then for the rest of the world, you may use a coarser resolution if that doesn't affect what you want a lot. We will talk about that later. This is the open source model. So we have to be specific when you run the numerical forecast model. What is the objective of your run? Usually you care for one city for our case. If you care for the whole world, that's the job of ECMWF or of NSAP. They they do global model of uniform resolution. But for us, usually we have a more specific targets, like you care for your city only. Say for Hong Kong, you want to make a prediction 5 days ahead for Hong Kong. So what do you need to represent in your model? Maybe you will think that you have to represent the terrain in South China near your region of interest, and also land use. And then how about further away, the Indo-Chinese Peninsula? And then maybe if a typhoon is coming, you may think about Taiwan and North Philippines. But for further away, do you need to represent every details of the land surface? Maybe not. So here is the techniques we are going to talk about in this course.